Okay, so the next problem in the lead code we are solving is minimum number of arrows to burst balloons. Okay, so there is some backstory. So to simplify, this is actually like, I mean, to just to summarize here, this is an interval based problem only, but we'll see like how this problem is described here. Okay, so basically what they're telling is we have a board and we have a balloons. Okay, like we can say that horizontal balloons. Okay, so we have a balloon here and we have a balloon here and maybe somewhere here as well. Okay, and what is being asked is how many arrows we will need to burst all of this, like, I mean, to burst all of this. Okay, that's one thing. And we'll be shooting our arrows in this direction. Okay, and let's say that if I shoot in this direction, right, it will go till end. Okay, it will go till end. So whatever the balloon that are present here, it will get cleared. Okay, this will clear only one, but if I shoot this arrow here, it will clear both of this, correct, both of this. And also, if let's say that there is one more balloon in this direction, correct, so if instead of hitting here, I will have to hit it here, correct. If I hit it here, it will clear all of the three, right. So this is the problem. So we'll have to find out what is the minimum number of arrows that will be needed, correct. So now what does it mean is like, okay, let's copy the input given. Okay, so this is the input they have given, and they have given us the range, like range of the balloon in the board. Okay, so it's a 2D matrix. So they have given from where to where the balloon is stretched. Okay, so let's say that they said 10 to 16. Like let's say that this is ranging from, what is the maximum value, 16, right? Let's say that x is 16, and it might be varying from 0 to 16, whatever the value, correct? Okay, so now this balloon is varying from 10 to 16. Okay, it can be placed anywhere across Y matrix, but it is just being told that this is the width. That's the only thing that concerns concern for us. So 10 to 16 is somewhere around here, right? It can be here, so it can be placed anywhere here. So let me just place it here. Okay, 10 to 16. This is a 10, assume this is 10, this is 16. Okay, and the next is 2 to 8. So next balloon will go 2 to 8. So this will be 2 somewhere, right? This will be, should go from here to here, 2 to 8. And 1 comma 6 will be where to 1 comma 6, right? It can go till here maybe, right? And 7 comma 12 will be like something like this one, right. Okay, so now this is the problem given. So what we need to identify is we need to we need to find out how many arrows we'll need to burst all of this, correct. So obviously, like if I hit this one, it will be one arrow, and if I hit this one, yeah, this will be two arrow. This is how, like, I mean, visually we can solve it, but practically how we are going to solve it, right. So just to quickly simplify this, right, not to overcomplicate things here. So we can just simply sort everything. Okay, like here now it is distributed, right. So we can just simply sort it based on this one, so that we'll know the track of the end one, right. So we'll do that first, like we'll understand like why we are doing it. Okay, so now 10 to 16, right, after sorting, how it will look, right. Sorting by the second one is, which is the minimum one, 1 comma 6, correct. 1 comma 6 will come here. This is 1, this is 6, and the next one will be 2 comma 8, 2, and second one, that is 1, right. Yeah, this is 2, and this is 8, and this is 2, and the next one is this is done, 7 comma 12. So somewhere here, to here, 7 and 12. Okay, and what is the next one, 10 comma 12. This is 10 and 16. 10 and 16, right. So now after we sorted based on the second value, it will always look like this, correct. It won't be like, let's say that it won't be like this is one range and it cannot go behind, right. It will always be like, this is the starting point, ending point. It will always be ending point will always cross this one, or it can go stop here exactly, but it will always cross behind this, because we have sorted in that way order, right. It is not possible that it cannot go behind, the next range will not go behind. That is the one thing that we need to keep in mind here. Okay, so now after sorting, it will look like this, any problem. Okay, so now what we'll do is we'll iterate through this thing, through this array, like after sorting. So what we'll do is we'll check the first array, the initially, let's say that the last arrow that was short, right, like let's say that that was short somewhere here. Okay, that will be some minus infinity or something. Okay, minus infinity or something will, but we'll still not consider that arrow because we are not shooting there, right. So that the arrow count will be initialized to 0. So now what will happen is, every time we pick the new one. Okay, let's say that I'm picking this one. Okay, like I'll be picking this one, and what was the previous valid endpoint, like, I mean, currently if we start from here, right, if I hit a balloon here, obviously I know this will get short. I want to now check if the next one gets short also, right. And also we need to make sure that, so only this part will be short, right. Like, I mean, if we short the here, right, the first balloon will not get short. So we'll have to find out a merged part, right. So what we'll do is, so first thing is we'll need, at least for sure we'll need one arrow, correct? So we'll set our arrow count to 1. So when we go to the next one, let's check that if the starting point is less than the previous short point. So the previous short point is 6, correct? The previous short point is 6 here, and the new point is, like, I mean, new point is 2. It is less than 6, it means it is falling within that range. So what we'll do is, okay, it doesn't need a new arrow, correct? So we'll just go to the next one. So it means that we don't need a new arrow, right? It will fall under our category only, so we don't need a new arrow. So we'll go to the next one. Here when we do this, this is our new point, and when we check, it is outside our end point. Last we shot it here, okay, within that range, this range, it is crossing that range. So it means that we'll need a new arrow for this. So we'll increment our arrow count, okay, and now we'll set our end point to this one. Okay, so that's how we can, like, I mean, this will be our new endpoint now. Okay, so now when we get the new arrow, like, I mean, 10, like, I mean, which is lesser than the previous shot, correct? It means that it will fall in the previous one, so we don't need to, we can reuse that arrow, so we don't have to increment our arrow count. Okay, so actually, yeah, this is getting complicated, I mean, this example. So let's see how it looks like, I mean, in a very simple example. Okay, let me just draw it quickly. Yeah, I quickly drawn this. Okay, like, I mean, let's say this is like ignore this. So this is the graph we have currently. Okay, so let's say that these are the our ranges. This is our the color ranges, right? Just by visualizing it, we can see that I can clear off these three balloons, like, just by hitting at this point somewhere at in, if I hit somewhere at this point, right? Obviously I know this will get clear, right? And also when it comes to the next one, and also here also I can, if I hit somewhere here, right, again I can clear off these three balloons, correct? And again there is some more new balloon, we can evaluate a separate arrow for it, right? So if you just see it here, like, I mean, we can simply rely on the last point. Okay, we can simply rely on this point and check the next actions, like, right, like whichever the upcoming balloons, if it is falling, which is less than this one, right, starting point is less than this, we can consider, or that can be hit with the same arrow, right? So that can be done here. So we are simply grouping it that way based on the last 10 to hit point. So this was the last hit point, and whichever the next balloons that are falling in the under it. So we got two more balloons, we can classify, group this one also, and we can group this one separately. Okay, then now quickly checking the code, right? So what we'll do is we'll sort it, as it said, we'll sort it based on the second one, so that we'll get that steep thing, right? Like, we'll be getting like this thing, right? It is not possible to go behind, right? So that is one thing. So we'll sort it, and we'll assume that arrow count is 0 for now, and last shot was something in negative infinite. Okay, okay, so now what we'll do is we'll iterate through, after sorting, we'll iterate through all the ranges. Okay, and if the start, let's say that we are picking anything. Okay, let's say that I'm picking this one, I will have to compare it with the previous last shot was infinite for negative infinite for this one. So this will be always picked when I'm doing the calculation for this. I'll be checking with this one, if the new yellow line is falling within that red range or not. Okay, so I'll be checking that if the start is within that last shot. If it is there, like, I mean, if it is not there, actually, let's say if it is start is less than the last shot, right? We are not doing anything, because we can reuse the same arrow, correct? We can reuse the same arrow. If at the when we run this loop for the first time, obviously the start, like, I mean, that will be this one, right? The start one, this point. Sorry, there is some, like, I'm too much of this drawing there. Okay, so the starting will be lesser than the infinite, so we'll be incrementing our first, we'll be taking our first arrow, and the last shot is the first ones, this one, we'll be picking this one. So every time we do this thing, we'll be checking it, like, I mean, if start is greater than the last shot, right, we will be incrementing our arrow count, or if it is falling within that range, we'll not be doing anything, like, I mean, because we can reuse the same arrow. That's it. Thank you.